Hello, my name is Marlene Gerbi. I'm a professor at the University of Pernambuco, and I would like to thank you for the invitation to give this conference for the direction of this great event, 75th Congress of the World Federation of Laser in Dentistry 23 in Poland, especially to Professor Aldo Brunera. We will talk about the impact of the use of artificial intelligence in research with laser photobiomodulation. Our team was work was uh, Maria Regina Menezes, Jéssica, Lara, Miranildo, Mávio Bispo, and Marci. I'm a coordinator of the discipline and specialization in implant dentistry at the FOP-UPE, professor of the permanent of the graduate and postgraduate program in dentistry at FOP-UPE, research coordinator FOP-UPE, coordinator research at the Center for Biophotonics in Dentistry at FOP-UPE, coordinator of the Technological Innovation Nucleus, NIT-UPE, member of the World Federation of Laser in Dentistry. This presentation will be covered in 4 steps. Introduction about artificial intelligence and data science. Part 1, STEAM seal research. Part 2, laser photobiomodulation. Part 3, practical applications conclusions. About artificial intelligence, the first steps in development of intelligent artificial took place in 1950 through Alan Turing. In recent years, artificial intelligence has been an essential tool in several areas of study and also in the market. Its applications range from automating human tasks, recommended content to prediction future events. Many of these applications have contributed to advances in biological research and also in medicine. Artificial intelligence is a broad field of research that aims to design computer systems that simulated human intelligence. In the last few decades, without even realizing it, a large number of people are constantly interested in artificial intelligence on a daily basis. For example, in medicine, diagnostic systems have used artificial intelligence to optimize queues in ICU beds, monitor in real time the condition of critical ill patients, and in many other applications. Artificial intelligence is an area with several sub-areas among which machine learning stands out. Then, about machine learning, it is a sub-area of artificial intelligence that is based on the premise that systems can learn from data, identify patterns, and make decisions with minimal human interventions. Machine learning explores the study and construction of algorithms and statistical models that learn from labeled training data from which they are able to recognize and infer patterns. Machine learning uses techniques from different areas such as statistics, algebra, neuroscience, and information theory to support and execute the training and learning process themselves. A supervised learning tasks consist of filter extraction, model selection, training, result evaluation, and finally perform the prediction and output generation. Our proposal will be to show of the impact of intelligent artificial in the research of laser photobiomodulation and present example of a research carried out at the Biophotonics Center of UPA of Brazil, where the accuracy of the artificial intelligence computer systems in obtaining results on the cellular differentiation of mesenchymal stem cells of the human umbilical cord was evaluated using the machine learning system. Part 1, Application in Research with Stem Cells and Photobiomodulation Laser. Well, the benefits. Process and analyze large amounts of data develop intelligent and automated solutions, efficient in speed, quickly identify patterns and valuable information that impacts regeneration medicine, improve understanding of disease, accelerate the research and development of new treatment in drugs, improve the quality of health care. About stem cells concept, they have the ability to differentiate in different types of specialized cells important for regenerative medicine. As some recommendations: repair or replace damaged or diseased tissues, development of treatments for different types of disease, diabetes, heart disease, spinal cord injuries, juice loss. About artificial intelligence and data science benefits for stem cells research. You can see identifies important images, partners, genes and proteins, quantifies and characterizes cells morphology and activity, high accuracy in the analysis and interpretations of data generated by surveys, improves understanding of stem cells behavior and its interaction with the environment, predicted results accurately and enable the development of new treatments, and analyze genomic data and identify genes and silence pathways involved in cells differentiations and regeneration. About laser photobiomodulation is a photonic therapy involving the use of laser photobiomodulation. Recommendation for stimulated cells regeneration, improved wound healing, treatment of chronic pain, diabetes, wounded and arthritis. Applications in medicine and dentistry, in physiotherapy, and dermatology. About laser photobiomodulation, artificial intelligence, and data science, we can see the benefits for research with laser photobiomodulation. Interpreted and analyze this data is the most important for us in this moment. Identify factors that affect therapeutic response, you optimize treatments protocol. About part 2, about technically laser photobiomodulation used by artificial intelligence and data science, you can see analysis of tissues images to quantify cell density and protein distribution, analysis of gene expressions data to identify genes involved in response to therapy, analysis and interpretation of data generated by these servers, identifies patterns and information used in the development of new treatment. Now, we show you the results of PhD thesis about the example of the use of artificial intelligence research laser biomodulation. The aim of the study was to evaluate the laser photobiomodulation at a red wavelength of 660 nanometer in the proliferation and odontogenic differentiation of mesenchymal stem cells from the human umbilical cord through the colorimetric assay of evaluation of cellular metabolic activity and the artificial intelligence program. Our specific purpose: to morphologically compare the potential for odontogenic differentiation of human umbilical cord mesenchymal stem cells through the stomorphometric and artificial intelligence program, submitted or not to the odontogenic environment, submitted or not to irradiation by laser photobiomodulation, submitted or not to the association of the odontogenic environment and irradiation by laser photobiomodulation. About the ethical aspects, it's okay, like you can see in these slides. After collection, the umbilical cord was processed in the biophysics and membranes laboratory and UFPA. The group of cells belongs to the group that would be radiated by the low-power laser was radiated according to the pre-established parameters 660 nanometer, 10 milliwatt, and 2.5 G. The laser, which was positioned 6 millimeters below the center of the well of the cutter plate so that the distance between the light beam and the surface to be radiated was constant. After 24 hours of plating, the cells belonging to the photobiomodulation groups were irradiated. Now we are talking about the results and discussions. For the colorimetry assay to evaluate cellular metabolic activity, cells were analyzed at intervals of 24, 48, and 72 hours to establish the cell's proliferation curve. It can be seen that the grid test cell proliferation was in the odontogenic plus photobiomodulation group. There was a statistically significant difference between all times 24, 4, 48, and 72 hours for each group. How can you see in this slide? About our second results, you can see that laser photobiomodulations always the initial significant increase of MS cells before differentiation, thus increasing the number of differentiated cells for tissue engineering and regeneration. About morphological analysis, you can see three kinds of days, 7, 14, and 21, from the beginning of induction. We here showing through the photomicrographs the images that were analyzed by the artificial intelligence machine learning system about the cellular odontogenic differentiation, observing the calcic nodules in red color. About our second results, you can see that laser photobiomodulations always the initial significant increase of MS cells before differentiation, thus increasing the number of differentiated cells for tissue engineering and regeneration. About the histomorphometric evaluation of the image was performed by a duly trained operator. These images were stored on a computer where measurements of the area of differentiated cells of the entire diameter of the well were performed using the Leica interactive measure model software. The graph shows the mean, that standard deviation of the odontogenic differentiation according to the group and the induction time. The images were labeled in magenta and black. The magenta color represents the target information of the images, and the black color represents everything that is not the target to be segmented in the image. The graphs represent the mean and standard deviation of the areas of the odontogenic differentiation according to the group and the induction times according to the artificial intelligence analysis. When we compare the graphs of histomorphometric with that of the artificial intelligence, you can observe a small difference in the results between the groups, evidencing the precision of the artificial intelligence method. The machine learning explored the study and construction of algorithms and statistical models that learning from labor training data from which they are able to recognize and infer patterns. Once trained, the algorithms always provide consistent results when the same data is provided. For the analysis of these experiments, image segmentation is performed with pixels are assigned to each image belonging to each cell individually. Without this mapping, it is not possible to extract statistical data. By learning a set of annotated data, new image reading can be performed with remarkable accuracy. You can see our conclusion. the potential for odontogenic differentiation of MSC through artificial intelligence, analysis highlights that there was a statistically significant difference between all experimental groups at all times when compared to the control group. We are now in the part 3, the practical application of artificial intelligence and data science in research with STEM cells and laser photomodulations. You can see analysis of large amounts of data and identification of molecular markers. For analysis of large amounts of data, you can see great speed and accuracy. It analyzes complex and numerous data. For identification of molecular markers, you can see identifies molecular markers. It helps to distinguish different types of stem cells and cancer cells. It helps researchers develop new therapies and drugs to treat stem cells related diseases and cancer. Continuing for part 3, we can see discovery of new drugs. It analyzes large data sets and identifies patterns that lead to discoveries of new drugs. It helps speed up the drug development process and reduce research costs. For gene expression analysis, you can see analyze the gene expressions of stem cells, identify genes that are turned on or off under different conditions. It helps to identify potential therapeutic targets and better understand cell regeneration mechanisms. Continuing part 3 about the practical application of artificial intelligence and data science in research with stem cells and laser photobiomodulations, you can see for drug discovery, you can identify new molecules that could be effective in treating diseases, including those that affect stem cells. Analysis on large databases of molecules identifies those with promising properties of development of new drugs. And for treatment customizations, you can see analysis of patients' genetic and clinical data and customizes stem cells treatments to meet specific needs of the patients, and it helps to increase the effectiveness of the treatment and minimizes side effects. Well, continuing part 3, you can see for modeling of cell interactions. Models interactions between cells, laser photobiomodulations, allowing researchers to better understand how treatments affect cells and identify new therapy applications. And for image analysis, you can see analysis images of cells treated with laser photobiomodulations, identify morphological and molecular changes, help to better understand how treatment affects cells and identifies new therapeutics applications. Continue part 3. For identification of side effects, helps identify potential side effects of treatments, allowing clinicals to better monitor patients and adjust treatments if necessary. For cost reductions, helps reduce medical research costs by allowing researchers to analyze large amounts of data more efficient and speed, accelerated the discovery process of new treatments and therapies, save times and cost. Continue improving the effectiveness of existing treatment. You can see helps identify how best to administer existing therapies, including dosage and durations of treatments, thereby improving its effectiveness. For prediction of clinical outcomes, you can see predicts clinical outcomes based on genetic, imaging, and medical story data. It helps physicians make more informed decisions about treating their patients. Well, continuing part 3, you can see for modeling to cells development. It created models of how stem cells develop in different cells types helps researchers better understand the biological process involved in cells development, identifies new therapy approaches, and for identifications of biomarkers, you can see identifies biomarkers that can predict a patient's response to photobiomodulation laser treatment, and it helps to customize the treatment and increase the effectiveness of the treatment. And to close it, the part 3, you can see improved the effectiveness of existing treatments, help identify how best to administer existing therapies, including dosage and duration of treatment, thereby improving its effectiveness. 4. Improved data qualify improves the quality of data collected in stem cell research. I ensured that the data is accurate and reliable. It leads to more accurate results and more reliable conclusions. 4. Search acceleration. You can see help acceleration medical research, enable researchers to get results faster and more efficient, and fast advances in regenerative medicine in other medical areas. Then you can conclude that the artificial intelligence and data science impacting on research with stem cells and with laser photobiomodulation as they accelerated the advancement of regenerative medicine and the treatments of various diseases. The practical applications presented show how artificial intelligence and data science accelerated and optimized searches, enable scientists to obtain more accurate and efficient results, analyzing large amounts of data. It is important that scientists continue to explore these technologies and discover new ways to apply them to generate greater quality of life. Now you can scan, use the QR code, and you can see the bibliographical searches. Once again, thanks the role teams, Visiomed Partner Company, PhD students, Miranildo engineer student, and Professor Maria Regina Menezes. And now you can see our contact, Instagram, email, telephone, and thank you, gracias, obrigada, thank you.